All right. John, you good on recording? I don't know if he's there. All right. Whatever. Okay then. So welcome everybody. My name is James Wong. I'm the chief engineer for the electric side of Spartan Racing, and here I'm here to present to you a Drawings 101 seminar. So I'll go over basically what I've learned and picked up about what drawings need to have, what should be expected on drawings, and then hopefully you'll learn something out of it. So to start with, I just wanted to go over where you can find some resources, especially since this is required for our cost report. So here I just put up the link for the cost report series resources. So you can look up the 2021 FC cost event description of kind of what the requirements are. And then they also have some reference documents that you can look at. So they have a cost module guide. This cost event rules supplement also, which describes exactly what is required. And then there's also like the template. There's the EBOM template, and the cost addendum template. That's not as useful, but yeah. So you can use this link, or you just look up FC online and find it in. I believe it's under here, competition info. Yeah. Oh, also, if anybody has any questions throughout this entire presentation, feel free to interrupt me, and hopefully I can answer you then. So for the 2021 competition, I just want to go over this briefly. So they stated that teams will have to submit a cost report detailing costs of their frame, body, and suspension sub-teams specifically. So I think actually this is a bit ambiguous to me right now. I think what they're meaning is that the frame and body and suspension are what's focused on, but we still have to submit the rest of the cost report. So the drawings won't be looked at in heavy detail, but we still have to submit the entire cost report for the vehicle. Uh, since this kind of contradicts what they say in the rules, which says the cost report must list and cost every part on the vehicle using the standardized cost tables. So we might do a rules inquiry just to make sure that's clear. But yeah, it's just make sure that you understand um, that the cost report is has more points allocated to the engineering drawings this year, so 15 points, and then 15 points for the cost accuracy. So it's a little more heavily weighted, and so this year we have to put a bit more focus on making sure drawings look nice and dandy. Yeah. So a couple more resources. There's some drawing template guides. So I've posted here the electric drawing template where you can find that. So you can find that in our CAD standards, GrabCAD. If you don't have that, make sure you ask a lead or me for access to that. And then you can find it in the MCAD drawing templates. And then also combustion, you guys have your specific drawing template that can be found in your, I think the top level folder of the drive, and just put the link there so you can look at that. And then I also added how to load the templates links here. I'll go over a little bit about how to do that after. I'll do a little run through of through SolidWorks, just to kind of show everybody how to do that live. So that being said, part numbering. So this is basically Formula S's, I guess, mandated off their EBOM, which is engineering bill of materials. So they basically give you a pretty it's pretty well thought out part numbering system. So you have your brake system, engine, drivetrain, and whatnot. So this designates your subcategory or your system, and then you have your base number for each part. So each individual part has like a 0007, and then the base number for each assembly, which is like A006. So that's the sixth assembly, um, and the eighth part for the balance bar here. And then the suffix for the rev level. So for example, if I'm looking for say if my motor is the first assembly in the engine, motor, or engine and drivetrain system, then it'd be EN assembly 1001, and then the 21st part of that assembly, and then rev AB. So you have to make sure that your drawings have that part number, and then each part number is specific uh, per the team discretion. So uh, I know we have past EBOM, so we can use a lot of that to reference off. But when we're making new parts and all that, we have to update the EBOM and make sure that all of that is accounted for. So moving on. So for part drawings, I've put a bunch of tips and tricks or kind of things you should always look out for whenever you're looking at drawings. So this is really the meat of this presentation. Um, so the number one objective of your drawing should be to convey your part requirements as clearly as possible. So like you can you can dimension a bunch of features on your part, but if it's not clear to the machinist of how to do it or how to make it, it's just not it's not a good drawing. You're trying to tell the machinist what are the requirements of your part, how do you what do you need out of it, and how can the machinist make it. Um, so keep that in mind. You want to have a really clean drawing and not cluttered, so that you can convey your information clearly. Uh, every callout is inspectable and therefore rejectable. So anything you put on the drawing, any dimension you put on the drawing, you're obligating your manufacturer or your supplier or whoever to make sure that they have that feature in your part. So if you put a, say like this radius at 1.75, you're telling them I need this radius at 1.75, and it's a two-place tolerance, so it has a plus or minus 0.01 tolerance attached to it. And say, or like I have this whole call out, the machinist has to have that. And if in industry, uh, where people have like quality control, if this goes into quality control and the machinist or the manufacturer has not achieved that tolerance or that feature, even if it say even if it works, like it's on the assembly line and it works, right? Or you could fit it up with the parts, it's rejectable, and that means that it has to be sent back to the manufacturer or whatever, unless you write like a variance to accept this part. But doing that is paperwork and money and time, so it's really critical that you stay cognizant of all the dimensions you put on a drawing, because if you have, say, like a long lead item or a part that is manufactured in high volume, you're costing your company a lot of money to have to go back and correct the drawing. So just be very careful with uh, whatever dimensions you put on a drawing, because that's a requirement you're putting on the supplier. Um, so added on to that, callouts should be measurable. So if you make a datum off of like some arbitrary, like a point or a line that doesn't exist. Say if I made a center line, a vertical center line for this hole, right? And then I try to I put an angle measurement off of that line, right? It's not easily measurable, and it makes a huge headache on quality. And then sometimes it could get rejected because they're like, okay, I measured it this way and now it's failing, and they have to send the part back. So one thing I wanted to add is I know this probably isn't the most relevant for FSAE, but in industry, all of these things apply. So if you come across like you making a drawing for a company, it's super important because engineers spend a lot of times correcting mistakes in drawings, and how those drawings turn up into manufacturing and supply. Um, Also, you should avoid over dimensioning and constraining. So if I say if I measure this 4.75 dimension and there's another way that I dimension this hole off, you're basically putting two requirements or over constraining your requirements to manufacturer. And sometimes if you dimension it off another point, then it'll cause issues with quality because now you have two chances of that dimension failing. And so if one of them fails, even though like one of them passes, that's still a failed part. Luckily, a lot of the CAD software nowadays, they basically are coded so that they don't allow a lot of overcontraining, but it still happens a lot. Another thing, I kind of already touched on this, large and clear views. You want to make sure that you use a decent amount of your space on your drawing so that your your drawings are easily legible and it's not misunderstood in manufacturing. I've had times where and this isn't really because it's just not a large and clear view on the drawing, but I've had times where I've had to work with legacy drawings and like a dimension. It was like a copy of an actual print and then digitalized, and there was like a smudge on a dimension, and so we had been sub or ordering this part, and it was just not fitting up correctly, and we had a someone on the shop floor. He had to have been grinding like a huge chunk of um, armor steel or armor aluminum, and that costs a lot of like manpower and time, and then no one could figure out why. And we realized when we looked at the drawing that the drawing had like a little fade of a dimension, and basically the supplier thought that was the actual dimension, understandably. And so all of that basically fed into us manufacturing an incorrect assembly. So always try to have a really clean drawing. If you keep JPEGing your drawing or something, shame on you. But yeah, just try to make sure it's readable and concise. You can also consolidate a lot of your callouts of like repeated features. So if you have if you have a hole pattern callout, like like you have a four hole pattern, you could do 4x and then the hole callout, so that you don't have to put hole callout on the top left corner, hole callout on the bottom left corner, and the third or the top right and bottom right. It just helps clean up the drawing and not make it super cluttered. Like so, for example, in this drawing, I put R.13 typical. So this TYP means in other features similar to this, apply a 0.13 radius tolerance or a 0.13 dimension tolerance at 0.01. So that helps clean up a lot of the detail and numbers off the drawing.
Hey James, can I add something real quick?
Go ahead.
So one thing, and this is kind of specific to FSAE stuff, but it's true I think in all cases. One of the big considerations that I think everyone should make, or not, I think in reality everyone should have when they're making a drawing. It's a little different for cost, but when we're talking about actual things that get made for whether it's for industry or for the team, is you really have to take the perspective of how it's going to be made into account. And so what you're seeing on your screen now is this is a what 3-axis, 5-axis CNC.
You could do this on 2 axis.
Oh, two-axis CNC. Yeah, yeah. So basically a mill. So in this case, right, if you're looking at these dimensions, if I were to go machine this, right, I need to start with a point, and so I'd maybe start with one of the top, upper, lower, bottom holes, and then you kind of go from there. And then if you're thinking about like a lathe, if you have a big cylinder with a bunch of notches in it, or it's a bung or something like that, you want to understand where the zero is going to be for the machinists, and then dimension from there, right? And so one of the big responsibilities of I think all engineers, but particularly on this team, and particularly for parts that we make in house, but also for sponsors, is you have to really research and think about how things are going to be made, and take that into account when you're putting your dimensions in. Because to James's point, you can have dimensions that totally and accurately reflect exactly what you want. But if they're not relevant to how the machinist is going to stick the thing in the machine, set it up, and then set his data points for him to go through and like either a CNC or it's a lathe or however it's getting made, it's really critical that you take that into account when you do drawings.
Yep, very good point. Design for manufacturability always. Whenever you're thinking of designing a part, making a drawing and whatnot, you have to keep in mind, do they have the tools to necessary to make your part? Do you have to find another supplier or something? Is your part too high tolerance for the tools they have? So I've been on phone calls where I've been talking to the supplier or manufacturer whether or not they're able to achieve this tolerance. And sometimes that's what your job is as an engineer. You have to make sure that your part is viable. So yeah, thanks for bringing that up. It's also a really good point about choosing your datum correctly. You want to make sure that you can find something that the machinist can locate easily and reference off reliably. Otherwise, you're not gonna reference off like a point off this corner of this radius. It just doesn't make any sense. So
Quick question.
yeah, go ahead.
So if we're assigned a part, then how do we determine like the tolerances? Are we given the tolerances or are they like in a spreadsheet somewhere?
No, so you should understand what the requirements of your part is, or what requirements of that part. Like, what is its function? That's what drives ultimately the tolerances on your part. So if you have some non-consequential feature, say like a hole that it's a clearance hole that you just need to put I don't know, like a simple rod through. It's not like high tolerance, it's not a bearing fit or anything. You can use like two-place dimension. Typically, I would say 0.03 plus or minus 0.03 is a decent like not high tolerance dimension. 0.06 is super relaxed as well. So that basically means like you have an eighth inch of play that you can have in your dimension. But when you go into like three-place dimension, those the more precision you have means more cost. So you have to be careful in your tolerances because if the feature is not important, you shouldn't be adding more tolerance to it. Otherwise, you're making your machinist's life harder, you're making the cost of the part higher, and it's just not good for an engineering drawing. You want to reduce
Got it.
costs
Thank
all
you.
the, yep, sorry. Um, the added on to that, you can, I guess, on my point 9 here, title block tolerances, I probably should have put this earlier. But so there's title block tolerances here that I've been referencing. So you have to make sure that your significant figures of your tolerances are um, is thought about. So and you'll notice in specific places, I've left like 3 decimal place tolerances because this horizontal dimension, this 2 inch 0.000, I want it to be at plus or minus 0.005. So that means I have plus or minus 10 thousandths of an inch of tolerance. And if the supplier doesn't meet that, the part is rejected. So in other places, I've put, say, a 2.85 diameter. This inside diameter here is not very important, so I relaxed the dimension a bit and put plus or minus zero point zero 0.01, so that's a zero point zero 0.02 tolerance, or I guess play that they're allowed to have. In other places, say right here, I've added a bilateral tolerance is plus zero point zero 0.00 minus zero point zero zero 0.001. That means from this nominal dimension, 3.148, they're not allowed to go any higher than 3.148, but they're allowed to go down minus zero point zero zero 0.001. And this is a hole call out or with a depth of 0.555 and diameter 3.148. And this is a critical dimension because it fits a press fitted bearing into this hole. And so the tolerances are very high because it is a critical dimension. So you have to always think about, what is the function of your part and how does it play into your tolerances, so you can avoid unnecessary costs, lead times, and like tooling setups and all that. Next is notes. So these are pretty important. I know a lot of times people don't put that much detail in it, but they can sometimes be an engineer's best friend. So a lot of the times you talk about just general notes of the part that the supplier should know. So let's just go through them. The first one's all dimensions apply after finishing, plating, and heat treatment. So that means I have a finish here that says clear anodized per mil spec A8625 type 2 class 1. So that means all these dimensions apply, but after anodization. So the supplier has to understand that they have to account for the increased thickness of the anodize, which could be like just barely a couple thousandths, but still meeting these tolerances. And then,
I have a question for you.
oh, sorry, Josiah, so you.
I have a question for you. Are you expecting the same person that machines parts anodize it?
So that can depend on your supplier. I've had suppliers where they can do all of it in a go. I've also had suppliers who would ask, or they would machine it and then send it off to anodize, but that would be all done on their end. Um, Usually, I guess it depends on what tier the supplier is in the manufacturing process. I know, I guess in other tiers of this supplier, they'll like I said, bring the anodization to another place to do it, and then you might want to have this like a separate note on a different drawing and not have it applicable here.
Okay.
Yeah.
Yeah, so I was just going to mention if it's, I know some parts for us, we have one person machine it, then we actually go there, pick it up, and then bring it to somewhere else. So maybe if you're going to do something like that, just make sure that you give them, don't make the manufacturer calculate that if they're not going to be doing it, or they don't know how.
Yep. Yeah. So kind of going further with the notes. So parts to be free of all sharp edges, burrs, chips, and shavings. That's a pretty standard note. I already went over the finish. You can look up this mil spec, but sometimes they're held by there's a paywall behind them, so it kind of makes it difficult to know what spec you need to call out. Usually your company should be paying for access to see those specs, but and then all radii to be 10 or a tenth of an inch unless otherwise specified. So anywhere I haven't called out a radius, it's assumed to be a tenth of an inch. And then here I have a hex note. So you'll see this a lot of times in industry where they use a hex note to apply a specific instruction to a feature or dimension. And so here I say on note 5, hex note, no finish. So I put that hex note 5 here and it refers back to this. So this means that in this whole callout, I don't want any finish, so no anodization. And that's important because to maintain this tight tolerance, I don't need that. I don't need anodize, or I don't want it. So sometimes you can add hex notes that have really special instructions, like if you have an assembly drawing, you could put a hex note, say, with this part, apply this lubrication spec, blah blah blah, and you can get pretty complicated with the notes. Like you can say for this part, match drill with using this part, blah blah blah. So you can get creative and sometimes kind of cut around the corner if you need to, but you know don't abuse it as much as possible. And then section views and details views. So here I have a detail view, detail C here that points out this corner specifically. So you should use these to your advantage when you're trying to get a view of I guess a zoomed in snapshot of a certain location on the part or assembly that might not easily be readable just from these normal views. And so sometimes you can put in some callouts or special instructions on really intricate features that are important. So a lot of times people use this for like, so I have the section view B-B, which shows this section view here. If you imagine your eyes as these arrows and then looking, um, basically if you, I guess, I think of it as if your part is on the table and then you're looking at the part if it's like flat on. I don't know if that was a easy or a good way to describe it. But essentially this section view shows this whole call out, or the midsection of this whole call out. So those are really useful for showing intricate details that are vital to your part. I already went over note 9, and then for 10, make sure you keep tolerance stack up in mind. So when this is especially important when you have like big assemblies, and sometimes you'll find that the tolerance stack up wasn't really considered during the design, and so you'll see that it won't fit up at assembly, and then now you have an issue of like, why doesn't it fit? Oh, it's because the tolerances weren't tight enough that at one range of the tolerance it was able to fit, but then on the other you can't fit it because it's just now interfering. Um, so example of that is, or what tolerance stack up is essentially I have this 4.125 dimension and this 2-inch dimension here. Now, each of these individually have their own 3-place dimension applied. So the plus or minus 0.005 each applied to it. So 4.125 plus or minus 0.005, and then 2 inches from that plus or minus 0.005. Now, another way I could also dimension this is I could bring this dimension to measure against this specific feature rather than the center of this hole. Now what that does is now it's a single dimension and it's 6.125 and applied with a 3-place tolerance plus or minus 0.005. That means that it's making the tolerance tighter because now you don't have 2 title block tolerances applied to it. And so stuff like that, when you have a big assembly or like really tight fitting parts, it really does matter that you consider it. There's been many occasions where I've had to do tolerance stack up analysis and found out that the tolerances here are not controlled tightly enough, and so then you have to write paperwork to fix it and revision the drawing and whatnot. There's other stuff I haven't really gone over the drawing. So like this revision block, I think that's pretty self-explanatory. That's Rev 01. You want to put in simple descriptions of what the revision is doing. In this case, it's an initial release of this part. Other times you could be like, say if I had to fix the dimension on a hole, you just say then the description of what that rev is, and then obviously date and who it was approved by. Here in the title block, you also have material. Sometimes I've seen in drawings, if they want to specify optional materials or they have more additional stuff they want to put about the material, they just put a hex note, and then say if it was hex note 6, it just replaces with hex note 6 and then type out the material and then the optional material, what spec it is, and then what other requirements. Same thing with like, so finish. I mean, here it says C notes, but you can also do hex note here, and then you could put in like a paint spec, primer, and the spec that calls out the process for applying the primer and paint. So it can get pretty detailed. Here it says interpret dimensions and tolerances per ANSI Y 14.5M. I think now it's called ASME. It's like the American Society of Engineers or something. I forget. But it basically lists out the ways to read and interpret dimensions. So this is a really standard note to have. There's this remove burrs and sharp edges. So this is a roughness, surface roughness callout. So it's like 125 micro inches. So if you need to have like even smoother surface, you can lower this tolerance. There's the signature date thing. This isn't super important, but it's just nice to have when you need to reference if a part goes wrong or you need to ask the designer how this is made. Sometimes you can ring them up and ask them, hey, why did you feature this part like this? Or what's the intention of this feature here? Third angle projection, that just tells you the the kind of view angles that would come out of, say, like I'm looking at this part and you flip it. It's whether or not you like flip it outwards, like to the right, and you'll see this, or if you flip it to the left, would you see this? In this case, it's not super important that you understand. You can look it up of how they explain it with a really good diagram that explains it, but this basically just tells the representation to display your model like how it is shown here. And the dimensions are in inches. That's pretty self-explanatory. Then you got your part name. So this is the mount for the right differential. And then size B of the drawing. So that's, I think in this case, it's like 17-inch by 11-inch paper. And then you have the drawing number or part number. So I talked about this before. Engineering or engine assembly 34, 8th part. And then the rev, this is still rev dash because it's initial release. Scale 1/4, that's pretty self-explanatory. None of this. And then sheet, there's can always be multiple sheets to a drawing. If you need to have a concise drawing, you can add more sheets, more views, just as long as it's clear and not redundant. You don't want to, obviously I already talked about this, over constrain something that you've already dimensioned. And then something else to note is the borders here, 4, 3, 2, 1 here, DCVA. So these are all referenced to your zone. So sometimes, like if I have like a big drawing or multiple sheets of a drawing, sometimes you'll need to note, say like sheet 2, zone 4D, and then I'd look at sheet 2, zone 4D for where this section view is called out. And so you can tie it all back. In this case, because it's only one sheet and it's small, you don't really need to have it. But then other times you'll see that that's important. Any questions on this? I know I went over a lot, but that's mostly what a good
I
drawing takes.
I have a few questions. So the first one is, since some of us are not doing the designs but just the drawings itself, how do we know what to communicate or what should we focus on?
Yeah, so in this case, for chassis or frame, body, and suspension stuff, I think it's important that whoever's making the drawing does at least understand what the function of that part is, and then so you can understand, what kind of tolerances you need to put on that. Even though if you aren't a designer, you should understand what it needs to do. It's fit, form, and function. And if you don't understand it, talk to a lead. Maybe they can clear some stuff up with you. But to be like actually accurate with your drawing, it's necessary.
All right, thank you.
Yep. Anybody else with questions? No. Okay. So I'll talk a little bit about assembly drawings. I don't have as many notes here because kind of most of the rules apply. But in assembly drawings, obviously, they convey how the assembly is put together. So this is a steering rack from SAE 4, and it shows the individual parts that go into making the part. So these are bomb balloons. Um, Sometimes they just show the item number and not like one with a line and then one. So what this means is item one, a quantity of one, or here it says item 10, a quantity of two. So you can look at this bill of materials. Usually it's right above the title block, but in this case, because this exploded view is reaching out all the way here, they decided to put the bomb on the left here. But so there's a couple things wrong with this drawing. Like it doesn't have notes. So when you're assembling this, if there's something that needs to be considered, um, it's just not there. The revision block isn't updated. Uh, there's a material for an assembly drawing which doesn't really make sense finish. It would make sense for assembly drawing if you had like a paint drawing or paint spec that you're calling out, and it's like this entire assembly would need to paint. Uh, in this case, we don't paint our steering rack, so it wouldn't make sense. What's also missing from this drawing is a next higher assembly call out. So usually you want to say what's the next highest assembly for this drawing. So this would probably report up to steering, um, and then you would call out the entire like steering assembly. That's really useful for when you just have a drawing and you need a reference back to it. Sometimes you can use the E-bomb or engineering bomb to look back at what assembly it reports to, but it's often convenient to have it in the title block. And then obviously it's missing drawing number, then update on the rev and whatnot. So this one in particular uses a exploded view of how the part is put together. Not as all assembly drawings need to have this. It's just there to more easily convey what's built into the assembly. Oftentimes it's used for items that have internal parts that you need to kind of uh, convey or show. So it makes sense for this assembly to have there. Um, I've already talked about bomb table and bomb balloons, and then yeah, notes. Like I said, if you want to apply some special assembly instruction that isn't conveyed from just straight up reading the drawing, then you should put it there, such as lubing some gear or something. Uh, yeah. Any questions on an assembly drawings or anything?
I have a devil's advocate question.
Yeah.
So let's say I'm making my first drawing, and I need to change something in the in the data block. How do I do that? Because I know it's going to happen as I go to click on it, and nothing's clickable. And
Yeah,
I
the
can't.
title block, right?
Yeah.
Yeah. So I was gonna go over like a live creation of a drawing.
Oh, okay. Never mind.
Yeah.
Sorry, I retract my question.
Yeah. That's all right. Um, but any questions for this before I?
Yeah, are you gonna go over like how to upload into GrabCAD and stuff like that, or should we already know how to do that?
So I don't know where Combustion wants to upload their drawings. I guess for now, for the electric drawings, I'd say just put them in the folder that the part exists in, and then we'll have to put them specifically in the cost report individually afterwards. I know in SRE 4 we just put them in a cost report folder. I don't know, it makes sense to me to put them in the folder that the part exists in so you can easily locate it. But
Yeah, I would agree. Yeah, for combustion, same thing. Put
Okay.
all drawings in the folder with the part, because what never fails to happen is you make your drawing for your part, because you have to send it to a manufacturer because it's cost, and you save the drawing and you save it somewhere, and then you send it to where you need to send it, and then 6 months later you get the part back and it's ruined or whatever. You need the drawing again, and you go to open the part and you go to find the drawing and you can't. So
Yep.
just always with the part. in the same
Right.
exact file. Yeah.
Thank you.
Yeah, I've already found that happening with all the SRE4 drawings. So I'm trying to use those for reference. So, all right, anything else? I think I'll go into a little bit about GD&T. I know everybody kind of hears what GD&T is when they're talking about drawings, but GD&T is a system used to define and communicate tolerances for specific critical features. So some of those are features like flatness, which is really useful for defining a surface that needs a gasket or like a sealing surface. That's super important. Or you can have like a positional, locational tolerance that you need to define like a hole pattern or something because you got a part that has a specific tolerance that needs to mate up correctly. So GD&T is kind of like its own like library of I guess maybe not as expansive as the library, but there's plenty of them here. They're like symbolic to kind of represent what kind of feature you're trying to apply. So they're useful for conveying tolerance requirements to manufacturers that conventional dimensions can't. So it's not super easy to convey that you need a flatness across this entire surface within, here it says 3/1000ths of an inch. So this flatness says that I need on this surface here, apply that flatness. And then there's also like run out or concentricity when you have like cylindrical parts or shafts that need to mate up together correctly. I would avoid using these as much as possible because oftentimes it just makes it harder for people to understand your drawing. Sometimes they're not easily measurable. People have to use special tools or have special setups to be able to measure these callouts. So you should only use these if it's absolutely necessary to convey what you need to convey. And then I found that sometimes people they just like they'll read a position tolerance and then they'll just use that dimension as like a straight basic tolerance or not basic but like a normal tolerance. Basic tolerance is actually something else entirely. But if I would, like I said, try not to use these unless it does actually make sense to your part. Otherwise, it may just add confusion and more cost to be able to inspect or qualify it. I wouldn't really worry about these for cost report drawings, but I think it is still useful for engineers to see or know about it. And kind of, I'm not going to go into the minute details of it here. You should be able to read up on it on your own. It would take, it's basically like a course to try to teach this stuff. So, and just a reminder, everything is inspectable. So anything you put on there, it's subject to quality rejecting it. And so you have to be very careful. Is this call out necessary for your part to function? But yep. Any questions on GT&T or GD&T I can answer? I know I didn't really go into the specifics, but all right. So I left a space here for questions, but I don't think anyone here has any questions for that. But that being said, I'll just go ahead and try doing a live drawing making. I won't go into a complete drawing making, but just maybe a couple of the clicks here and there that people might find useful. So you should be able to see my SolidWorks here. All right, so here I've got a pretty simple part. It's a little bracket for chain guard. So to load up your templates, you'll need to locate it here by clicking the options button. Then you go to file locations, and then you can add wherever your template is located. So here I've added the GrabCAD, CAD standards, MCAD, BOM templates, note blocks, etc. Here. So if I do that, I should be able to start a new drawing from this part, and this drawing template should pop up. And then click OK. And then here on the right side, I could drag over whatever view I want that I want to put up on my drawing. So the template will automatically generate whatever size the template was created as, size B. And then because I made this part, or made the drawing relevant to this part, it just automatically selects the part. So I'm just going to drop this in here. So usually it's really good to have like a projected view just to get the supplier or manufacturer a simple idea of what the drawing looks like. Sometimes when you have a CNC machinist, they'll ask for like a step file already, so that would already be communicated. But it's always nice to be able to see on the drawing kind of an overview shot of what it is. And then say I want a side profile shot here, so I can call out the thickness of the material that I need this to be. And then these are all views that I wouldn't need because I could dimension everything off this. So these look like pretty good sizes to clearly represent what I expect out of this part. So I can move this. I can smart dimension this diameter 0.250. I'll keep it at 3 decimal places. This doesn't need to be super high tolerance, so I'm going to turn down the tolerance here and this tolerance precision block to 2 place. I could also, so like if this is a high tolerance, I can change this to a bilateral tolerance and then define it. Let's say for kicks, this is a press fit. So it's roughly around 1,000ths tolerance. So there's that. And then you want to define, say, like the relationship between this radius here, that's 1/8 of an inch, and you go on and measure that. So I'm not going to measure the entire thing and whatnot. I'll leave that up to everybody here. Let's see what else. You can add notes. Oh, so to John's question, so I'm trying to change the title block. I'm clicking, nothing's happening. Well, to fix that, you can, I don't know why they call it sheet format, but it is. And so now you can actually edit this title block. Say I don't have a drawing number in yet, I can add the note by clicking the note button. Add this little box here. Let's say it's EN A0005 008 rev. I guess we don't have to put the rev here because there's a rev block already. So let's call it that. And then you can change this rev block. Let's say it's first rev, materials, finish note, blah blah blah. So you can change the title block tolerances too if you want. I've found that this 0.01 is it's a bit tight for a 2 place, to be honest, and then 3 place, that's fine. At least I've seen 2 place be like 0.03, which amounts to 0.06 play. But yep. And then I would change the revision block. You'd say this one is initial release. Then we got your date, obviously. What's today? The 31st of January, 2021. And approved by myself. And then say you can look at all the features that you have here, at least for this this draw or this part. It's not really intricate, so I think I can add a center line here. I'm not sure actually. I haven't used this feature in a while. Nope. Yeah, I'm not entirely sure. I could look that up if I need to, but say like you want to call a whole call out that instantly tells you what the whole call out needs to be. So if you're like looking for a thread or something, or you need to define a thread, sometimes you need to say like uh, quarter inch. If you use the whole wizard on SolidWorks, it'll let you do that. But so yeah, I can say like quarter, yes, quarter. Oh my God, quarter 28 UNC was like 28B or something for a quarter 28 thread. Um, and yeah, let's see what else is up here. I guess there's like simple GD&T callouts that you can make here, and then also calling out a datum for GD&T. But so I think that's the basics of a part drawing. Does anybody have any questions on this?
Can you import a bunch of dimensions for your part instead of doing it like manually?
I'm not aware of that. At least I've never seen that. I've never seen like an auto-generate dimension thing.
I
There
think if you
kind
go
of
to the
is. You can go
dimensions,
to model items,
Oh
I
yeah,
think.
yeah.
tips and tricks.
And you can choose under dimensions what you want. Like, yeah, right there, you can hold your cursor on top of it and you can choose stuff like there's stuff for like hole wizard and stuff and tolerances as well. And it kind of automatically dimensions a lot of the stuff. You can take some out.
Okay.
Yeah.
Yeah, so I guess that would be pretty useful. Yeah. I never knew about that. I've always done it one by one, but nice. Anyone else know any tips and tricks that I might not know about? Yeah, so oftentimes in different CAD softwares, a lot of the buttons are a little different. Generally, the things you need to have done are the same. It's just whether or not they make it more easily accessible for you as a designer. Um, in in most cases, I've found that SolidWorks makes things really easy to make drawings. In other cases, like Creo, I've had a lot of heartburn with how the software is made. But yeah, any other questions or comments on this? No?
I'd say one thing, not about this particularly, but about drawings and SolidWorks files in general. Um, always send a manufacturer a PDF of the drawing and a step file, because we have the newest version of SolidWorks, and many shops don't have even 2020 yet, and they won't be able to open your files.
But yeah, that's a good point. Yeah, and I found that in industry, if you send a drawing, typically that is the holy grail for that part. Basically, it's blueprint. So even if you send a step file, they still have to build it to the drawing, and the step file would only be used as reference. Now that's only some cases. In some other cases, if you communicate with your supplier, you can say, I don't need to actually dimension everything on this drawing because I'm giving you a 3D model of what it needs to be. And then
Yeah.
you can just dimension the critical dimensions that you need on the drawing. So
And some suppliers, like if we're going to give them a complicated part, the drawing definitely helps for like holes and stuff, but the OD and everything should be what do you call it?
critical.
No, they call it what's it called? Machine to CAD or something like that.
Okay.
Reference to CAD. So they're going to use the CAD, put it in the software, and then use the drawing only for critical features.
Yep.
One more thing too, this doesn't really apply for FSA too much, but in industry, I know it's a trick that's been used on me, and I've used it on others as a result. and it's called the was it Brown M&M rule.
Sorry, you cut out there for a sec.
Um, and this was a trick that it's sorry. Oh,
You're kind of like in and out.
yeah, my internet's bad. Is it better now?
Yeah, it's good.
So it's just a little trick you can do sometimes, and I wouldn't do this too much, but if you have a new sponsor or a new supplier and you're sort of vetting them, right? One trick that I did on companies and companies did to me when I was like doing machine stuff was you set a little trick, not a trick, but you set a little small feature, a small datum that is insignificant, right? And you have them, you check that as one of the first things you check when you get the part back. The famous story behind this is that I think it was Van Halen used to say in their like one sheet for when they did tours and like concerts, they would say that in the like the green room behind the stage there had to be a bowl of M&Ms, but they had to all be brown M&Ms. And the theory was that if a contracted like provider for the event like this the venue didn't follow that one insignificant rule, what else did they not follow, right? And the I don't know if it's true or not, but it's allegedly for that particular story there was a venue where they didn't do that, and then the stage ended up collapsing because they didn't follow the guidelines for how to set the stage up for their particular set, right? And so that's something you can do too. You can do it within the team as well. You can do it like, hey, I'm going to send this drawing to someone to check out. Like if you're going to send a drawing to Ross or me or James, and you want us to check something for you, like something that's really important, like it's something in the suspension or it's a critical bearing, set a little extra thing in there and make sure we check it and make sure it's a good little way to double check things. Obviously, don't do it to be mean, but that's one of the things that I've learned in industry that is a really good way to make sure that the communication goes 100%. You know.
Yeah, that's a very good point. I've found that at least at the company I work at, we spend a lot of time fixing drawings because when it gets to assembly, for some reason it's not working, part can't fit or they can't weld apart because the tolerances aren't right. So we have dedicated drawing checkers to look through the drawings, and even then, like there's for all of our drawing revisions or paperwork, there's a huge round of engineers looking through it, and even then we might not capture everything. So there's always little mistakes here and there that might cost the company more money because it wasn't checked correctly or it wasn't drawn in a very good way. So you want to reduce scrap and waste as much as possible, and making sure you do due diligence to have people check it and you check it yourself is important. That's why on the title block itself it says detail. So this would be like the designer to sign and check, and then be checked by your lead, and then approved by, say, the chief engineer or your engineering manager. So there's always huge amounts of checks going to drawings because they're they're costly. Any more Any more comments anybody want to make? Okay, I have an assembly drawing that I could try to go over a bit. So here's our little power pack assembly. Um, we don't need to make a exploded view for this, but just for the sake of doing it, I will. But you can basically call out all the simple or independent sub-assemblies here just from this shot itself. But let's say I wanted to make an exploded view of this assembly. Hit exploded view up the top here. Let's say I added a step of making this sub-assembly. Let's move that up here. Done. Boom. I'm gonna move this guy up here a little bit. And then let's make one more for this tray here. Now I could explode view the hardware, but for the sake of time, I'm not gonna do that right now. So let's say I wanna have that in my drawing. I make a new drawing from this assembly using this template. Boom. And then I can drag this isometric exploded view here and have exploded view. And then I could put like, I guess not with an exploded view, but sometimes you want to put like major dimensions of the entire assembly. So like just height and length and width. Let's say I want to make this a little bigger. Let's say 1 to 4 scale. Blow that up a bit. Let's put that there. Let's put in a bill of materials. And let's put that here. So that goes up wherever I'm going to click. I don't know why this is 7200, but let's change that to 1 motor controller. Otherwise that'd be expensive, very expensive assembly. So one thing I'd also like to say is your BOM also drives your, well, at least what we call at my company MBOM, which is manufacturing BOM, and they use that to procure whatever items that they need to procure. So if these quantities are wrong, it can be very costly to your company. Say if you had like this motor controller at 7200, now you're forcing your supplier to purchase 7200. Usually that'll be, they'll see that instantly, but sometimes it's like little things here and there where there's a lead that is a long electrical lead that's a long lead time item, and they can't procure it, and you have the wrong quantity, and then that brings a bunch of errors. There's also like obsolescence parts that aren't used that you'll have to make a revision for, or pay a huge premium to get that thing made. So just keep that in mind. And then you can add your bomb balloons. So I can use the auto balloon feature, and it'll simply just balloon all the subassembly items here. So let's do that. Or you could individually balloon it if you want, but in this case it's a bit easy to do this. So let's just say it's like that. I'm gonna shrink it for a second, and then you can move it around, and then just make it neat and easily readable of like every component. And you just put that all on your drawing. And yeah, and then I would put notes. Sorry, somebody had a question? No? Your notes one, assemble with care. You wouldn't really put that there, but yeah, if there's any special like safety instructions or something, you would put that there. Material that obviously not applicable unless you got like a paint spec that you need to call out or something. Um, but yeah, that's a simple overview of an assembly drawing. Maybe I can, let's do simple. I don't know why it's not. Oh, I don't know why. Alright, let's try model view. Let's not do exploded view. Actually, can I change it from here? There we go. Okay. So maybe I want to do just like the simple like dimensions. This is probably like fitting too much on the drawing, but just for example's sake, um, probably don't need that for dimensioning it. Delete this guy, and then I would advise not putting a lot of stuff here, because if you have like a lot of revisions and then it eats into your drawing, and then you have to do another revision just to move the drawing views. Um, and then same thing with the bomb. If it gets in the way of the bomb, you don't have space. I would just like put it on another sheet.
So that's something I haven't really tried to do yet. In drawings, in one drawing file, you could have like multiple sheets that link, say like that each item you have ballooned, and then you could dimension them. Say like you can have like 4 different parts on one sheet, for example.
4 different parts on a sheet? I've never seen that actually.
Yeah, like I've seen Moy does a really good job of it. I see his drawings at work. But you have the main assembly drawing, and then I think you can like down there on the bottom right, you can like click add sheet or something like that, and then you could instead of using like 10 pieces of paper or 10 different drawing files to make the assembly, it's all in one.
Yeah, so I have sheet 2 here, and then I don't know why this view isn't updating. This should not be exploded. Oh, there you go. So let's say I want this 1 to 4. And then bigger assemblies, obviously, it's gonna ask a lot more of your computer to load. But let's say I want to do actually another projected view. It's just the bottom, and then I can start measuring. And then sometimes you'll see drawings where it's like these parts are specifically from another supplier, and the assembly drawing is just like putting the parts together. And so sometimes you'll have like source controlled drawings, which basically means you're making a drawing that is for your internal use, to say that we're purchasing this part from this certain supplier only, because they've done the testing that you need it to have done, or uh, they've just made reliable parts or something. So let's say this is like the widest part of the part. These are just like major dimensions. Boom. And then let's say measure that this fitting. So I have the major dimensions there. And then let's say the bottom of this bolt is the lowest end, and this connector is that high. So sometimes you'll do a simple drawing. You don't have to do like be super accurate for the rest of the other parts, but unless it's like you want to make sure that this part fits up with other stuff correctly. But yeah, and then finish it off with your title block, and now you have a 2-sheet drawing. Delete this guy. But yeah, that's about it for assembly drawings. Anybody have any questions? No? All right then. Well, that's kind of all I had for today. I hope everybody got something out of it and learned something, a thing or two. But yeah, thanks everybody for joining. Appreciate it.
Yeah,
Thank
quick question.
Oh,
Thank you.
yeah.
uh, for the CAD standards, should we just download that on our desktop and then use that to import it onto SolidWorks?
Yeah, I would use grab or the CAD standards, GrabCAD like that.
All right, cool.
Yep.
And then follow that document that Kirby sent.
Yeah, yeah. I think so combustion should have their template on their drive separately. So I've linked the Google Drive link to that in the slide deck.
Right. Okay. All right. Cool, man. Thank you for the presentation. It was good.
Yep. Problem.
Okay.
Cool.
Thanks everybody.
If you have any sheet metal drawing questions, I can answer them too, or maybe next time.
Yep. I think Josiah does a lot of drawings and a lot of manufacturing, so he can help a lot with any questions you guys have.
Yeah.
See you guys.
Yep.